Hello everyone, welcome back to our channel. Today we will be solving one more interesting problem, that is problem number 238 of LeetCode, that is product of array except self. So let's go through the problem statement. The problem is quite straightforward. We will discuss that. So we have been given an array of integers. We need to return a new array such that each element of new array is the product of all elements of the input array except the element at that position. So basically what we need to do is we need to exclude the element at the current index and find the product of the remaining elements. So let's get the question in much simpler manner by taking an example, and let's understand the problem in much deeper manner. So basically we have been given an example array nums, and 1 2 3 4 are the elements inside it, and the output we are getting is 24 12 8 6. So if you guys can see what is happening here, basically at index 0 when we are there, the element is 1. So we will exclude the product of this element and we will multiply it with the rest of the element, that is basically 2 into 3 into 4. At index 0 what we are doing is basically excluding this element and multiplying other elements with each other, like 2 into 3 into 4. So what is the output in the first go? That will be 24. Okay, so in the first index the element is 2, so we will exclude 2 from the product. So what will happen is basically we will multiply with 1 into 3 into 4, so the output we will get is 12. Similarly at index 2 the element is 3, so this time we will exclude 3. So after multiplication, like 1 into 2 into 4, we will get the output as 8, and at last at index 3 we will exclude 4. The output we will get as 1 into 2 into 3, that will be 6. So I'm trying to tell you all is basically for the first index, as you all can see, we want the product of all elements except the nums of 0. So 2 into 3 into 4, as I told you. Okay, and for the second index it's like 1 into 3 into 4, that is clear. We have to exclude basically the present element, and we have to multiply the other elements. So at example 2 also you all can see we have been given an nums array and inputs are -1 1 0 -3 3. So the output will be like at the first go, if we multiply at index 0 we are having element is -1, so we will not multiply -1 and we will multiply rest of the elements. As you all can see, there is 0 in this multiplication, so the rest of the output will be 0 only. Okay, similarly at index 1 we are having elements as 1. Again, if we multiply -1, if we multiply exclude 1 and multiply, if we exclude 1 and multiply with the rest of the elements, we are again getting -1 into 0 into -3 into 3, and if 0 comes in the multiplication, the final output will be 0 only. Next time at index 2 the element is 0, so we will exclude 0 from the multiplication. So this time we will multiply -1 into 1 into -3 into 3, so this time the product we will get is 9. After that we all can see that again we will not be excluding 0 and we will be at -3. Then every time we are getting 0 in the product, so the final output will get 0. Since there is, so what I am trying to say is basically there's a 0 in the array, so any product involving that 0 will result in 0 except when 0 gets excluded from the product. Okay, so let's get let's get into the brute force approach, how we can think of it. Basically we might solve this using like 2 nested loops. But basically what we can do is solving this would be to calculate the product for each index by iterating through the entire array except for that index. Okay, and how we will be able to do this? Basically with the help of nested loops. So let's see the code for the brute force approach, how we are doing this. Okay, so we are having a result vector. We have initialized this result vector. This will store the final products. Okay, we will be taking the variable product to store the product of all other numbers except the current one, and this is the outer loop which iterates through each element of the input array nums. We will reset the product to 1 for each new iteration of I. Okay, and we will also use this inner loop, and this is called the nested loop, which will be iterating through each element of the input array nums. And how we will do this? Basically, this is the if condition. We will skip the case where I and j are equal. We don't multiply the number by itself. Okay, and we will multiply all the numbers except for the current number at index I. So similarly, this is the condition, and later on we will store the computed product in the result vector that we declared above. So finally we will return the result, and this will not work according to the problem statement, as we will get the runtime error. So we will be taking using the this will the time complexity for this will be like O of n square, where n is the length of the input array and the space complexity will be O of n, as we need to store the result array. Okay, so this solution is okay for small arrays, but it's inefficient for larger arrays, especially when the length n reaches the upper constraint of 10 to the power 5. So now let's talk about a more optimal solution. So our goal is to solve this problem in O of n time complexity and O of 1 extra space complexity. Okay, so what we will do is basically to achieve this, we will break the problem down into two parts. That is, first one is prefix product, that will be the product of all elements to the left of each index, and second one is suffix product, the product of all elements to the right of each index. Okay, and then we can compute the product of array except for the current element by combining these two parts. Okay, so as you can see, I have done a try run for the example 1. So basically the nums array is 1, 2, 3, 4, and we will calculate the prefix product. Okay, so we will start with the prefix product is equals to 1. Okay, for index 0, the result 0 is equals to 1 because there is no elements to the left of the 1. So its a prefix product will be 1 only. But for index 1, we can see result 1 is equals to 1, prefix product into is equals to 2. So we can see prefix product is equals to 2 because at the left of 2 there is 1, but it will not cause any effect as multiplication with 1 will give the same result. And for index 2, the result 2 is equals to 2, but the prefix product we have to multiply with 3. So the prefix product will be 6 because at this time we are at 3 and we will be multiplying with the left part, that is 2. So 3 into 2 into 1 will give us 6. Okay. Similarly, if we have to maintain the prefix product for the left part, and for index 3 the result will be like at 4 we are having 3 elements at the left part, so we will multiply with the 4 with the 6 that we have maintained. So 4 into 6 will be 24, and in the result array we are getting 24. After this step, the suffix product calculation we will do, and at the suffix product part we are having 1, and at the right of it we are having 2, 3, 4. Okay, For index 3, we are having result 3, and after this we will be like multiplying with the result of 3, that will give us 6. Suffix product in 2 is equals to 4. Similarly, we need to calculate it using this method. Okay, and for index 0 we can see result is equals to 24. You all can see how it is 24. Like at index 0 we are having 1, and at the right of it we are having, if we multiply 2 into 3 into 4 we will get 24. So at the right of it 24. At index 1 we are having 2, and at the right of it we are having 12. Okay, and at index 3, at index 2 we are having 3, and at the right of it we are having 4. Okay, and we will multiply with the suffix product in order to get the final result. So final result we will get is 24, 12, 8, 6 in this case. Okay, so this is how we have to solve the problem. For this, the time complexity will be O of n, where n is the size of the input array. We only loop through the array twice. Okay, once for the prefix product and once for the suffix product. So the space complexity will be O of 1, excluding the output array. Okay, let's go through the code for the optimized solution. Here is the code. We are initializing the result array with 1, and we are computing the prefix product. We are initiating with 1 to store the cumulative product of the elements before each index. We are iterating, we are using for loop, and we will set the current element to the prefix product. Okay, and we will update the prefix product for the next index. Similarly, what we have to do next, we have to compute the suffix product, and we will update the result array. Okay, to store the cumulative product of elements after each index, we are initiating suffix product is equals to 1. Okay, then we have to use the for loop in order to multiply the result by the suffix product, and we have to update the suffix product for the next index. Then we have to return the result.